Hello, so today we are going to take a look at functional interfaces in Kotlin. So a functional interface is basically an interface with only one abstract method. Sometimes you may hear them also called SAM interfaces, which is just single abstract method interface. And what this boils down to is that it has one abstract function. And in Kotlin, you need to mark it with a special modifier called fun. So here, usually the interfaces is like this. You need to add this fun modifier to the interface definition so that it can be considered a functional interface. And it has to have only one abstract function. If we try to do two, for example, Kotlin, the IDE complains that functional interfaces must have exactly just one abstract method. Okay, so you can't also have abstract properties as well. And so here, for example, if we try to define an abstract property, we get an error that functional interfaces cannot have abstract property. And so, but you can have other non-abstract functions, like functions that for which you provide the implementation, for example, here. The other thing is that it cannot be like without any abstract functions. So if we comment this one, we would get that functional interfaces must have exactly one abstract method. So at most one and at least one. And then yeah, you can have you can like not have default functions, other non-abstract functions, but non-abstract functions are allowed. You can have as many of them as you want. You can have more than one, for example. Okay, so that's about the syntax and what's allowed inside a functional interface. Now let's take a look at an example here. So the first example we are going to take a look at is this int predicate, which just checks something for an int value that we pass in a check function and returns boolean true or false. And the uses of this, let's say we have this function, maybe let's call it test or something. And then we have an int predicate, pass it as a parameter. And so the way to call it, we just say predicate.check, so like any interface, and then if it's valid, otherwise we return false. Okay, and so in our main function here, if we want to call it, let me just make sure there is no other conflict. There is, let's call this 6 or something. Okay, so the usual way to call it without single abstract method conversion, which is usually called SAM conversion, is verbose, because you would have to define like, so for example, test needs the value, so let's say 3, and we want to check if it's even or not. And so we want to implement int predicate that checks if an int value is even or not. And so to do that, we'll have to have an object and then say the type is int predicate and then override the function check here and then check if it's even or not. And so you can see this is very verbose, right? We ideally want to just provide the lambda, and that's exactly what SAM conversion gives us. So because we define it as a functional interface, we can actually do this where we just pass the value, and so this initially is like this, so we can pass it as a lambda, but just since it's the last parameter, we can move the lambda out of the parentheses, right? If it wasn't a functional interface, if it was just an interface, you can't do this, right? Because it's you can do with the lambda. And so so even if you do something like, let's try to do, even if you do something like int predicate, provide the type like this, it still doesn't work, right? Because it does not have the SAM constructor here. But if we make it a functional interface, now this works, right? And it has a constructor for this, and since we can just make it just a simple lambda, right? So this is because it's a functional interface, we can pass it as a lambda. Otherwise, we would have to use this really verbose form, right? And so it's a way for us to make Kotlin less verbose, to have basically a less verbose version. You can also assign the functional interface instance to a variable the syntax for creating a function when for basically putting it in a value for a functional interface is just the interface name, and then between brackets here you put the body. So for example here the interface is int predicate, and then we want one that checks if a value is even, and so we put the body for that inside the brackets here, and we can assign that to a value, and then we can just pass that value to test function, right? And so again, this is also not possible without the functional modifier, right? Okay, because it does not have constructors there. Okay, so so that's about like why is it useful. This is the main goal of using of having functional interfaces, to be able to write something like this and have a defined type for the for whatever we are passing to the function. One thing you may wonder, okay, so predicate, maybe you will say, if I'm passing a parameter predicate like here to the check function here, to the test function here, maybe you'll say, I don't want to call that check. Maybe you want to just do something like this. You want to just call the predicate on that one. So if you want to do that, you can take advantage of something in Kotlin called the invoke operator, which basically allows parentheses to be translated to calls to invoke with the appropriate number of arguments. So this means basically now when you call predicate, which is the parentheses with an argument, it will be just translated to invoke with these same number of parameters that are here, that are defined in the function. And so if we want to use that, let's say for our int predicate, so let's define a new version. Instead of having a new function, let's say check, like we did here, we can just have an operator invoke implemented here, and now in our test function we can just call it directly instead of having to do that check. So this will be translated to invoke, to a call to that invoke. So, but instead we can just do this. Okay, so another thing we can do with functional interfaces is that we can return functions. So for example, here I have a functional interface, math formula, and it has a function value that gets passed an int and returns a function from an int to int. And so you can see here, if you were to use a function type instead of like codifying it in an interface, you would have to say this function here is an int, takes an int as a parameter, and gives you as a result a function type like this. Okay, so you can see this is harder to read than if you define an explicit interface with a name and then have the function have the parameter here and then the function parameter as the return type. And so this is a lot more clearer than having just this type. So now in a function that uses math formula, you can just have the parameter have the type math formula instead of having this type, which is more complicated to read. And let's see an example of the usage of this. So to do that, let's enable this main function here. And let's say we have a math formula that gets passed a value that is times, and then we just multiply whatever is passed to this new function times x. So whatever is passed to it, we multiplied it by times. So with this now, we get a functional interface that has this value function that returns a function that basically multiplies a value by times. And so we can define times 2 by just taking times x and passing 2, right? So now we have a function that multiplies whatever is passed by 2. And so we can call now times 2, and whatever is passed is 5 will be multiplied by 2, and we can have 10. And so you can see the reusability of this. This would be, you could do something like this, for example. And now you could do maybe 5, something like this, times 3, 5, right? Let's say times 3. So let's run this. So this should be 15, right? Okay, and that's what we have here. Yeah, so you can see it kind of made this easier to reason about. Instead of having a complex type, you can imagine this being, you pass a function here that returns a function, which would be even more complicated. Okay, so another thing I want to talk about is using functional interfaces versus function type. So a function type is just like this, for example, saying a function that receives parameter int and returns an int. So this is a function type. And if you take a look, for example, at our predicate here, this can be defined as a function type, this predicate here, where basically we get past an int and we return a boolean, right? And so this interface can be codified also as this, right? Or let's say call it predicate, and the function type just from an int to a boolean, right? And so let's just talk about what are the advantages and disadvantages of using functional interfaces over function types. So the first thing is that with a functional interface, you have a new named type for the function type. So it's not just like the signature. You now have, it's not just the types. You have a name associated with it, and you can even have a function like we did with int provider with check. And it also allows adding non-abstract function and implementing other interfaces. So for one function type, you can't have this, but for a functional interface, you can, like we did here, add other behavior, add other non-abstract functions. The other thing is also it can implement other interfaces. So you can have this here, for example, you can have it, let's say, implements, for example, int predicate. Right, and then you could have it, for example, specify, okay, this is, yeah, because if we implement int predicate, because int predicate has already an abstract function, we would have two abstract functions. So let's just have another interface, something called other. And so you can see here, we can actually implement that interface, right? Let's say that interface can have some behavior, right? And you can extend another interface, right? So that's another advantage of functional interface. Functional interfaces are also a place to attach documentation about the contract, right? With a function type, there is really no great way to do that because you don't have a way to name the function. For example, here we name it run. We can name the parameter. You don't have that with a function type. And so you kind of have more capabilities to name things with functional interfaces. One concept though with functional interfaces is you can't inline them, but you can inline function types, right? I think one big thing that factors in the decision of using a functional interface or a function type for a use case is basically, the main thing in my opinion is that a functional interface is giving the function a name, right? And the name is a vocabulary that needs to be learned and that has a cost, right? Because it's something additional that you need to know about. And so that cost is justified by facilitating communication and like AGE auto-completion and all of that. And so the question, I think, the main question becomes, okay, is this thing that I'm trying to use, that I'm trying to decide whether to use a functional interface or a function type for, is this thing a concept that is frequent enough in my system to warrant giving it a name or not? And so if it's used a lot in multiple places, then it definitely seems like a functional interface would be best suited. And so now let's just take a look at example of using a functional interface and a function type just to see what the difference is. So let's say I have a task data class, and then I have a functional interface executor that just has a run function that gets passed a task. And I have a run block that gets passed the task itself in the executor, which is the functional interface. And I have another version that instead of getting past a functional interface, it gets past a function type task to unit, which is the same as the signature for this interface because it takes a task and returns a unit. It does nothing, so it returns a unit. And so the difference is with the executor, with the functional interface, we will explicitly call run on the task, and here we will just call the function that we get passed. And if we take a look at the main function here, you can see the calls are the same. So I call run a block, pass the task. This is for the one that uses the functional interface. Or I can use the second version that gets passed a function type. And both you can see are pretty similar. We just pass a lambda that prints something. So both are very similar usage. The main thing is in the definitions here. Okay, so now that we saw the difference between functional interface and function types, there is another thing you can use, which is type aliases, right? Because if, which is an improvement over a function type, because if you have a complicated function type like the one we saw above, where you have maybe something like int, for example, then you can actually just use a type alias instead of functional interface. And this can allow you to give it a name, right? One difference though is that with type aliases you can only have one member. With functional interfaces, as we saw earlier, you can have multiple non-abstract members or functions. And functional interfaces can also implement and extend other interfaces, like we saw with the difference with function types. Another thing to mention as a difference between type aliases and functional interfaces is that functional interfaces give you more control. They are more strict with the types, right? Let's see an example just to demonstrate this point here. Why functional interfaces allow you to be more strict with the types. So let's say I have the same executor interface that we defined here as a functional interface. Let's define it with a type alias. Let's take the function type and make it a type alias. So let's call it executor2, and we have it as a type alias for the function type, task as a parameter, and returns unit. And so let's have another run block that gets passed the type alias. It's similar to this one, but instead of passing the parameter is a function type, it's the type alias. And let's actually just see the usage here. So the usage is the same, right? So we pass a lambda, and here to this one with the type alias we also pass a lambda, so the usage is still the same. Both still print the same thing, right? But to demonstrate this difference that functional interface is more strict, let's say we have a different type alias. So this was more just demonstrating the usage, but this is specifically to demonstrate this. So let's say we have a type alias success handler for success handler, which is just a function type that doesn't get past any parameters and just returns unit. And let's create success handler. We can do something here. That is just an instance of success handler of this type alias. And let's do something similar for another handler as well. It has a similar type alias. It has a similar function type, parameter nothing, and 2 unit. You can see here with the type alias, it doesn't restrict the type. We can actually assign something that has a type error handler. We can assign to it something that has a type success handler because they have the same function type, right? If this was different, this won't be possible. But since they have the same underlying function type, you can actually assign a value with the different type alias to the same with a different type alias to another type alias, like here. And so the type here is not very strict. And if this was a function parameter, let's say we have a function something that has a parameter error handler, right? And we tried here, we can actually pass a success handler, right? So the function can be, it's fine to call it with a different type alias, right? And so this can be done with functional interfaces. That's why I'm saying they are more strict, because let's say we define a success handler as a functional interface instead of a type alias. And so it has let's call it success handler 2 just to make it compile. And it has a function that gets past nothing and returns a unit, so similar to the signature here. And let's have also an error handler similar to the signature here, right? And let's try to do the same thing, basically assign something of type success handler 2 to something of type error handler 2. And so I have a success handler of type success handler 2 of this type. If I try to assign it to an error handler 2 here, you can see it doesn't compile. It says there is a type mismatch, right? Because there is a real type, unlike type aliases. And a similar thing, if I try to do, let's put this main down here. If I try to have a function similar to this one that accepts error handler 2, right? So let's call this something 2, right? You will see here, if we pass success handler 2, it doesn't compile, right? Because it's a different type. And so you can see how functional interface will give you more strict typing here. And yeah, so that's pretty much what I wanted to cover. We saw what are functional interfaces, an example of using them, how they allow us to use SAM conversion for a less verbose code, and different other capabilities. And then we saw also the difference between them and function types and type aliases. So that's it for now. Thanks for watching and see you on the next one. Bye.